And I'm going to start with topology, right? So the network is basically consists of different stuff like topology, how your network connectivity is going to happen, how much speed basically you guys need, the customer needs, what is the cost, what the security features are, what is the availability. What availability is basically for how long your network is going to be up, what is the downtime would be. Scalability is basically growth, right? Let's suppose if you have currently five employees and you put your network devices into a company, so then expect some growth in the next 2 years or 3 years or 4 years. They might go up to 20, 25, 30 people. So you're not going to be changing the network design every time. You need to make sure that you design something for the next 5, 6 years. So let's suppose if they have 5, 10 people, uh, you know you don't put 24 port. You need to put 48 port just in case if they start to if they need to add more employees to the company, right? So scalability is basically the growth. So you don't want to design every year, right? And it all boils down to basically how much money the company is going to be spending in order to get higher speed, because the higher the bandwidth, basically the more cost is going to be. If you recall what I said before, is um, 80% of the traffic in the past was staying within your network, and then 20% was going out. Now the things have been reversed. The things have been is now 80% of the traffic is going outside of your network, and only 20% is staying within. So that's what you have to put your calculations in it also to see how much bandwidth you need from the telco, from an ISP. So the higher the bandwidth you get, the more cost is going to be, right? And security feature, every company has got different security feature. Let's suppose I work in Google in YouTube department. What is the most things I will be using? The voice, the video, right? And any company which is dealing with security like firewalls, they will have different type of hardware, different type of iOS. And if you recall, in a couple of classes ago, I mentioned iOS, and iOS is what? It's like an operating system on your desktop. You have Windows 10, Windows 7, and whatever that Windows XP, whatever that is. Same thing is with all the network devices. May it be Juniper, may it be Cisco, may it be Arista, Ciena, whatever the devices are, they all have iOS. So iOS is like an operating system. So whenever you buy a hardware from a vendor, you have to tell them whether what kind of features you need in it. Some people say, we just need enterprise. We're not going to go a lot of security. We don't need a lot of security. We don't need a lot of voice over IP. But some people say, what? We're dealing with a lot of voice over IP. So we need iOS or a software to be installed on the hardware on the network device, which deals with a lot of voice over IP. Some companies they're dealing with security, so their iOSs will be different. So every vendor, whenever you buy a hardware from any of the vendor, they will have different iOSs basically, depending on the customer requirement, right? So the physical topology, cables, network devices, end system like PCs, servers, what do you need? Logical is the path over which the data is transferred in the network. It describes how network devices appear connected to network users. So basically, how do you want to design it? Do you want to basically, load balancing? Or do you want redundant path? When I say redundant path, it's basically, let's suppose you have connectivity to the outside world through only one router, right? If that connection goes down, you guys are done, right? Till that connection comes up, then you'll be able to start communicating with the outside world or outside network. But if the company says, no, we want more redundancy, we don't want downtime, so basically you can give them a dual connection. What dual connection does, it says, okay, you have one primary path and you have another secondary path. If the primary path goes down, at least you have the secondary path up all the time, right? So a lot of companies, what they do, they outsource their networks to companies, and they sign an SLA, it's a service level agreement. What it does, it says, what, we'll charge you $2,000 per month, and then we will make sure that 95% of the time your network is up, your connection is up, right? So they always give them the dual connectivity to the outside world. If it goes down, if it's less than 95%, then what happens? then those companies who are managing your networks, they're going to pay you some amount of money, whatever the amount of money they discuss in the SLA, and they will pay the company back, saying, you know what, we only kept our promise. Instead of 95, we only had 90% of the time. So the 5% of the extra downtime, the company would be paying, that the company who's hosting all their networks, they'll be paying the company themselves, right? So we talked about speed, we talked about security, routing. Routing is the most important thing in any organization you go to. Basically, even if you look at our boxes, right, at home, what do we have in our home? We have got a router or a modem, you want to call it. It's basically from Rogers or Bell. So basically, if you want, let's suppose I'm sitting here and I want to go to somebody who's hosting a server in China, or some site I have in China, what would happen? Do not want my router or my modem sitting at home to drop the packet, even though he does not know how to get to the destination, but he should have a way of forwarding to somebody else who might know how to get to it, right? Because the whole internet concept would be flushed down the toilet if we do not know how to get to the destination. Now, I have Rogers, right? So if I want to go to www.bbc.com, my Rogers might not know where bbc.com is, right? Then it's not supposed to drop that packet if he doesn't know. He's supposed to send it to some other router. If that router doesn't know, he's going to be sending it to some other router. If he doesn't know, he's going to be sending it to some other router. So basically it gets hop to hop to hop in order to get to the destination. That's how this whole internet is built. Even if you don't know, do not drop the packet, because the router is the one who's the deciding factor in order to make sure that your packet from source to destination gets to the destination and it doesn't get dropped in between. Otherwise, the whole internet would be collapsing. And this is the case. So routers in LAN and WAN, basically you have a home office, just like in our environment we're talking about. Central office, branch offices. Now, these branch offices could be anywhere, right? A lot of companies, they have one office here in Toronto, other office in Montreal or in Quebec, wherever that is. They might have some servers sitting in Quebec office, branch office. They might have some servers sitting in the Toronto office, depending or how many people are sitting. And you always want to put the servers where the most employees are sitting. So let's suppose in this scenario you have got 100 people sitting in central office. You want to make sure your exchange server is sitting here, and your other main servers are sitting here. And only in your, let's suppose in Montreal you got 5 people sitting. So basically you're not going to be putting too much servers over here. Let these guys come to this central office and then download whatever information they need, right? Because everything gets is cost affiliated, right? Because once you're going to have too many servers sitting over here, what would happen is you have to buy license and everything, right? It's a cost cutting. Best path determination, the router uses its routing table to determine the best path to forward the packet. When router receives a packet, it examines the destination address, searches for best network address match in the routing table, and basically if the table entries also include the interface to be used. Once the match is found, the router encapsulates the packet in the data link frame of the outgoing or exit interface. So what they are saying here, what this whole thing is this is your router. Packets come in, let's suppose from here, and it wants to get connected to somebody over here on this network, right? And let's suppose these guys are sitting over here. So what happens? Packet comes in here. Router, the first thing he looks at the routing table. That's how routers basically select the path. What they're saying, router has to say, okay, the packet is coming from this IP address, and he's trying to access an IP address over here. Okay, so I'm going to be looking into my routing table, and then I'm going to decide how I'm going to route this packet and through which interface I'm going to be exiting it out, right? So all this information is in the routing table. What about confidentiality? Uh, Confidentiality, integrity, and availability. Confidentiality, integrity, and availability. If you look at this, Wahid, Availability is here. Your confidentiality is here. And what other you said, you stuff you said? Integrity. Integrity is basically making sure that whatever you have sent, you have received it, right? So reliability. So wait, everything is right here, my friend. How do you want to interpret it? It's up to you. So routers support 3 packet forwarding mechanism, process switching, fast switching, and Cisco Express forwarding. So the process, so let's just look at this. What process switching does is basically the packets come in, they look at for source and destination, and they basically send it out, right? Fast switching is basically they just look at the destination and they don't care, they just select it out, right? And it's not going to do any error checking. Ceph is Cisco Express Forwarding. It's basically a table. It creates a cache table. What it does, that if my first packet has gone from one end and exit interface is this way, let's suppose A, B, and C, there are 3 exit interface. And if my exit interface is going through port A, then what would happen? My next packet comes in for the same destination. I'll be just simply forwarding it out to that port A, right? Somebody else typed something? No? Okay. So the home office device connect, laptops, tablets, right? They connect to the wireless. Network printers connect using an Ethernet cable to the switch port on the home router. Home router connects with the service provider cable modem, and the cable modem connects with the ISP network. So basically, well, this is not correct. Your network printer connects using an Ethernet cable. You can, I'm not saying you cannot, but most of the printers, they're coming up with, what do you call it, the wireless, right? So they are wireless basically. So it's just like if you look around in your home environment, what is happening, your home device, as I said before, it acts as a DHCP, it acts as a wireless router, it acts as a switch, it acts as a your default gateway, and I'll explain the default gateway later on. So it does a lot of these things for you. Branch site device connect, corporate resource, file servers, printers connect to layer 2 switches, PC and voice over IP phones connect to layer 3 2 switches, laptop smartphones, WAPs connect to switches, and edge router connects to the ISP. So what they're telling you here is you have, let's suppose you have voice over IP, and in the couple of classes ago, I mentioned, I drew the diagram for voice over IP. How does voice over IP gets connected? You got a laptop, connect to your voice over IP phone, and the cable is coming from the voice over IP phone. It goes to your wall jack, and it goes to the switch, and then switch is basically PoE, which is power over Ethernet, and that's how you got voice and your data also going through the same pipe, right? But you see, like when you're at home, and if you're trying to talk to somebody back home, what would happen is somebody you got, sometimes you will get a very chatty, conversation, very blur, videos and everything. But that is basically what is called FIFO, first in, first out. Whatever has come in through the pipes, going to the destination, it will get through, even if you're sending your data, even if you're sending your voice and video. But in a corporate environment, what is happening? We are using something called QoS. QoS is quality of service. And because in the beginning, we had a very bad voice over IP signals, calls were getting dropped, a voice was not clear. So what they did, they introduced quality of service. What quality of service does, it says, okay, my friend, whatever, let's suppose I have 1 meg bandwidth. So they say the through quality of service, there's a lot of configuration in it. It says, okay, any voice and video comes in, I'll make sure I allocate 60% to the bandwidth for that. 40% of the remaining bandwidth, I'll probably use it for browsing. I'll probably use some for email connections and all the other data. So what I'm trying to do, I'm trying to prioritize my voice and video to go through first through those pipes which your data is also going through. Comprende? Understand, guys? Right? So that's what QoS was introduced, and that's why things are getting a lot better, because you see, one company is not just located at one location, they're located at different locations. So if the companies are basically, in different countries, imagine how much money you guys are saving in long distance calls. All you have to do is just pick up the phone and start talking, and there's no cost to you. You're already paying for that pipe which is connecting you to the destination. Understood? Yes, no, could be, might be. Okay.
Yes, yes.
Okay. Let me ask you something, guys. Uh, if I have an office, one second, I want to see something. I want to see, get your concept clear a little bit. If I have an office here, right? I got my router, I got my switch, I got my PCs over here, right? And I'm sitting in Toronto. Then this is another router. This is my Toronto office, right? This is my UK office. I got a switch. I got PC sitting here. So I pick up the phone and I tell a telco, maybe it Rogers, Bell, or Telus, no matter, whatever it is, right? And I say, look, this is my address, whatever, blah, 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 my address is here, right? And I got an office here in UK, blah, 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 whatever the address is over here. And I said, I need a connection. I need end-to-end connection. So tell me, are you guys going through and they say, you know what, the whatever whoever the telco is, they will give you one cable and say, okay, you can connect it to your router here, and they will give you one cable to connect it to your router there. Now, what we learned earlier is basically public and private IPs, right? I talked about it when I was giving the lectures on IP addressing. Am I going through the internet, or I can have all private IPs over here? I want to make sure your concepts are clear. If I have a Toronto office and I've got a UK office, right? And I tell my telco, hey, my friend, I need a connection here, which is this is my address. I got my router here. I got my router on the other end in UK office. I need a 10 meg connection. So the telco gives me end-to-end connection, one in Toronto, one in UK. So tell me, am I going through the internet?
Yes.
Am I?
Yes, we go through the internet.
I'm sorry, sir. Could you please repeat your question?
My question is, I got a Toronto office and I got a UK office here, right? And I said I need an end-to-end connection, and they give me Rogers give me a cable here, and Rogers say, okay, you know what, this is your address. Whatever the local vendor is, he's going to give me a cable here to connect. Now, my thing is this connection between Toronto and UK. I said I need a 10 meg connection. Is my Toronto and UK going through the internet?
Yes, they are.
Anybody else?
Yes, sir. Yep.
Depends on
Vlan,
what. I'm sorry.
So, like by applying a different routing techniques, whatever they are supposed to use, and I believe that's how they're going to communicate with each other. They should there should be two IP addresses on both ends.
Okay. Wait, what do you mean by depend on what service you get from Rogers? If you have dedicated line, then you're using the line. What does that mean, my friend? Am I going through the internet? Yes or no? Wait, because I'm getting a lot of answers that we go through the internet, right?
Yes.
We don't go through the internet, my friends. Your answer is completely wrong. Everybody's answer was wrong. You don't go through the internet. Because what happens is, I tell Rogers, okay, I need a connection at this address. I got, they give me a cable connection over here to connect it to my router. Now, do Rogers have presence in UK? No, they don't. So they contact a telco in UK and say, I need a connection over here. This is the address. They give you one connection there. It's a dedicated line. When I say dedicated line, Rogers has got nothing to do. They're not going to be tapping anything in that line. They're simply going to give you a 10 meg connection end to end. You're not going through the internet. Why would you say that if you're going through the internet? Any one reason? Let me see who's typing here.
So the main thing was like if the packets are routing through the router from one end to the different end, like there is router A and router B. So what my understanding is through the internet, the packets are going to transmit from one end to different end.
No, my friend, because you see, God knows how many routers are in between. This for us is a cloud, not the cloud, we've been studying, right? Not the cloud nowadays. This is a cloud. We don't know what devices, from Toronto to UK, you got ocean and everything, cables going through there, right? And everything. So I'm getting a dedicated line from here to here. Everything can be private. Now, let me ask you something. Can private IPs go on the internet?
Yes, they can.
No,
No,
no.
only the
No,
public IPs can be.
We use public IPs.
exactly. We only use public IPs. We do not use private IPs on the internet. But over here, I can use a private IP. All I'm asking them to do is give me a 10 meg pipe to connect my two ends together. So when I connect my two ends together, it's a /30 IP address, which means I can put one IP in Toronto and I put one IP in UK. And whatever is going in between, it's not going to the internet. This is a dedicated line they're giving me. Understood, guys? If I go from UK office to the internet, then all my Toronto employees are going to be coming here to the UK office, and then from here they'll be going to the internet. But this is just a dedicated line. Understood, guys? Understood the concept? Yes, no,
Yep.
could be, might be. I lost connection. Well, you're in UK or what, right? Right? So basically, my thing is, this is a dedicated line between these two devices. You're not going through the internet. This is basically a simple cable connection from Toronto to UK. I don't care if it's going through the ocean. I don't care it's going to the mountains. I have no, control over it. I'm paying them money, 5,000 or 4,000. In return, they're going to be paying something to the, let's suppose, British Telecom, right? Okay, I need a connection. If a company is British Telecom and they have an office in Canada, they will be turning around and they'll be saying, "Hey, Rogers or Bell, I need I got a customer who needs a connection here," because they have got an infrastructure. Rogers, Bell tell us they have got infrastructure in Canada, so they'll be using their network. So these UK office, so use British Telecom and Rogers and all these guys, they share their each other's resources and platforms and infrastructure, right? And then they pay in return to them. So they might be charging me 5,000, they might be giving 1,000 or 2,000 to the UK office. But this is all private IP, my friends.
So
So,
mean that, yeah.
like we have internet at our home, and we are using the line, the DSL line of Bell, provided by Bell, connected to our home. But our internet is coming from Acanic, another service provider. So Acanic is riding or using the connectivity using the Bell copper wire.
Yes.
So there, it is kind of the same thing. So Bell is providing me, no, sorry, Acanic is providing me the service. Now that dedicated line from Acanic's office, from Acanic's internet to my home is no more called as a Bell line. It is now used by me and Acanic directly connecting me to them, right?
That's what they tell you, my friend. Acanic, whatever this Acanic is, you tell me, do they have an infrastructure in Toronto?
No,
Do
they
they have
don't.
underground cabling in Toronto?
No,
They
they don't.
don't. Who has the most? Bell has, the Rogers have. If you go to west of Canada, who has the most infrastructure? Underground cabling. TELUS has it,
Tell us.
right? So TELUS has it. So what happens is these guys, you pay them, let's suppose $60 or $70, right? A month. So I need the internet connection. What they do, they in return go to Rogers or Bell or whoever, and they use their infrastructure. Just like your cell phone, right? I got Chatter. And Chatter is with what? Chatter is with Rogers, right? So Chatter is using the Rogers, what do you call that, antennas and everything. They're using their bandwidth. So whatever I'm paying Chatter, Chatter is in return going to Rogers and say, hey, you go, my friend, this is your share. This is your cut. Understood? Yes, no? I
Yes,
need some kind of,
and they give us like for that they give us a private IP. Yeah,
I'm sorry, they give us what?
like one private IP to.
No, it all
Public.
depends. They may give a private, sorry, a public IP or
No,
static
I'm
IP.
sorry. They mean, it's not they may, they have to.
No, I know, but those are not the static IPs they have to provide. But Acanic had the services. They said that we can provide you a static IP, a static public IP,
Public
along
is.
with, so it depends on different ISPs as per their policy.
No, one thing I wanted to add here. If you are going to the internet, then there is no maybe. They have to give you a public IP. Understood? Within your own network in your home, everything is private IP. As I was giving the example earlier, if you look at mine, if you do IP config space /all, if you're with Rogers, you might all have the same IP, 10.0.0.0. Whatever. I think Bell is 192.168 0.1 0.2 0.3, if I'm not mistaken. Or sometimes they have 192.168. So everybody has the same private IP. But as soon as you go out on the internet, you get one public IP, and you have to get a public IP. It's not they may. So if I do a speed test, and I showed you guys here in my speed test, Rogers, this is my public IP. All my IPs, 254, is getting translated to this right here, 99.235.199.107.
Yeah, you can also check that what is my IP or something like that on the website. There is a website, what is my IP, or something like that. When you type in on the Google, it tells you this is your IP, this is your public IP.
Okay, can you guys hear me?
Yes.
Okay,
Yep.
Yeah,
because sometimes I just got a message that it's still it's connecting to the meeting, so something went wrong. Understood, guys? So basically, this is your public IP going to the internet. Inside is all your private IPs, right? So you have to, guys, this Aconnect has to give you one public IP. And all
correct.
your
So
200,
yeah, you're right. So the point was, I think the guy, when he mentioned He was trying to say, a static IP, a static public IP, not a, well, private came out from the mouth, but
It's
yes.
not a static also. Let me tell you why
I
it's not a
know, I
static.
know, I know. Yes, most of the time ISP don't give static IP, but they may give you a static public IP also, depending on the services. If you're purchasing, if you request them, they may add up some cost to it, and then they can provide a static public IP, which can be used to run a web server at your home also.
Absolutely. Then you have to pay extra price. But how many people are basically running a web hosting service from their homes? 5% of the population, right? 10% of the population. Companies are doing it. Companies are the ones who are basically buying the public IPs from them, right? But we don't get static IPs, public IPs, because you see what happens. What if I go on vacation for a month and nobody uses my my internet at home? What do you think that they're gonna have this 99 dots this and this public IP for me? Till the guy come back, they're gonna give it to somebody else if there is no traffic on it. Understood?
Correct.
So right.
Yes.
So basically, what happens is the companies they buy it because they're hosting the servers. But only 5%, 10% of the people are basically they're hosting this their servers out of 100% people, right? So if you take an average out, absolutely you will have to basically get in one public IP for that. Okay. So basically, this is what it is. So you guys understood the concept of this, right? So my next question was when internet was cloud. So my next internet is not internet is not a cloud. Wait, uh, that's wrong assumption. The internet is not a cloud. This is basically their infrastructure you're basically going through. It's a pipe you're going through. It's a dedicated line they're giving you, right? In 2006, the U.S. government asked AT&T to tap those private lines because they want to look at what kind of traffic. Because let's suppose I say, this is the example I was giving you, Toronto and UK in my earlier slide, and basically what happened was basically US wants to tap basically those private that given bandwidth lines, right? They want to see what kind of traffic. AT&T refused, but behind the scenes, God knows what is happening, right? So those are dedicated links, and they don't the telcos don't care. Whatever you're sending across, you're sending across. Understood? Once you go on the internet, then it's a completely different ball game. Then everything gets translated. So even in that scenario, my Toronto private IP, my UK private IP is all gonna get converted into one public IP address. Understood, guys? Any questions there? No questions? Okay. So the PCs and voice over IP phones connect to layer 2 Ethernet switch. This is what exactly I was talking about. That your voice over IP phones, your PCs basically get connected to your voice over IP phones, and then the cable is coming from the voice over IP and going to the PoE. There is a special kind of Ethernet switch, which is called power over Ethernet, that gives power also to your voice over IP device. Your voice over IP phone. So the layer 3 switch connects to the edge router, corporate website, service oriented to the edge router interface. So basically what they're talking about is layer 3 switches. Layer 3 switches is what? In the layer 2 switches, it doesn't do any routing, but it only works on the MAC address to the port. But the layer 3 switches work as basically like a router. It's a layer 3 router, right? You can do a layer 2 and layer 3 combined both. So there are high-end switches out there, 5200, 5500, 6500, 7200, 7800. Juniper has got a lot of switches. Arista, Sienna, a lot of switches out there. Layer 3 switches are out there also, but they're expensive. But if you got only a team of 5, 10 people, then you don't need to get into layer 3. Simply get a small layer 2 switch, 24, 25 port, more than enough, connect it to the router, and Bob's your uncle. That's it. Let's understand this default gateway. What is default gateway? Default gateway I explained earlier. If I don't know how to get to the destination, I will go simply to my default gateway. And default gateway is always your router end, which connects to the switch. They all have to be in the same subnet. So the default gateway is, if you want to go outside of your network, then basically you hand it over to the default gateway and say, my friend, it's up to you. I need to get to this destination. You know, you decide, you look at your routing table and get me there. In my example, in my example, what is my default gateway? My default gateway is this. This is my IP. This is my default gateway. 10.0.0.0, because the box sitting I have at home from Rogers, that is basically my default gateway. If I want to go anywhere outside of my 10 network on the internet, I'll be simply sending it my traffic to Rogers box, and my box is going to be looking at its routing table to see if I know how to get to it, and then it will be sending it out, right? So the job of a default gateway is basically for PCs. If they don't know how to get to it, simply take the traffic and then send it across. That's what the job of a default gateway is. Okay, got it? So identify the router to send a packet to when the destination is not on the same local network subnet. In order for this guy, PC1, to communicate with PC2, he doesn't need to go to the default gateway. He doesn't need to go to the router, because why? This is a /24 and they are in the same network. Understood, guys? This is administrative distance. Basically, in routing, what happens is these they have basically set the configuration in a way that if anything which is static, this is the routing protocol. Routing protocol is the one which decides how to take your packet from source to destination. Does it need different hops? Which routers it will be going across, right? So basically, there are different routing protocols out there. Enhanced Interior Gateway Routing Protocol, EIGRP. We are not using EIGRP anymore. I'm not saying that's just totally out of the window. It's not completely out of the window, because the problem with EIGRP is this is Cisco proprietary. It will only work on Cisco devices. If you have a Cisco and Juniper, Cisco and Arista, Cisco and Sienna, EIGRP routing protocol would not work on it. In 90s, mid 90s, Cisco was the king, and so everything was Cisco. So that's why we were using EIGRP at that time. But now EIGRP is less and less used, right? OSPF is basically open short path first. This is the routing protocol we are using. IS is basically the routing protocol you're using. Static routes are where we're using. Anything what this admin distance is basically anything which has a lesser administrative distance is preferred. That's all it means. Understood? So if I am learning something from static with one admin distance, and I'm learning the same thing with OSPF is 110, same network through OSPF 110, which one would I prefer? I'll prefer static, because why? The administrative distance is less than 110. Understood? Ping is basically pings is what? Pings is ICMP, right? And what this ping does is basically make sure the other end is alive. So if I'm pinging this puppy from here, or from here, from this device to this device, I'm sending 5 packets, and I'm coming here, and then it just says I'm alive, and he specifically sends a reply back. So this is ping is a tool which we use in order to make sure the other end is alive or not, or it's connected or not, right? So this is one of the tools we use. Telnet we use, ping we use, trace route we use, all these different features we use in order to make sure how we get to the destination. If ping is there, which means that the connection is there. Inter VLAN routing. Now, I'm gonna have to bring up the lab in order to explain this. Internet is part of cloud. Is edge router acting as CDNs? Ping is equal to echo. Wait, is this your comment or you have a question on this? I'm sorry, I'm looking at the chat a little late. Edge router is if you're trying to get to a destination, you know, it's basically one end is connected at your site, whatever your site is, and basically that edge router is taking you outside of your network. So those are called edge routers. Understood? Right? Ping equal to echo. Echo means what? Echo reply, right? When I send you a packet, I get an echo reply back from you. That's what it means.
Mr. Imtiaz, as far as I have read somewhere, edge router is actually the same as CDNs because the CDNs is the last what do you call it distance from the main routers. I mean that's the caching all informations by customers. So edge is doing the same thing, right?
Yes,
Edge routers.
exactly. Edge
Mm.
router is that whatever is behind your network, and this edge router through which you're going outside somewhere.
Mm.
There might be, okay, so in my previous example, here you go, look at this. Look at this diagram. I got Vancouver, I got Montreal, I got Toronto. And from Toronto, let's suppose that I'm going to the internet, right? So I'm going outside of my own company's network. So I can call this an edge router. Even though I've got two other routers, this edge router to take you to more different networks, right? So edge
Yes.
router could be anything outside of your network. You can call this an edge router. This is basically, connection. There might be two more routers here in Montreal, and this is at the end of it, which connects to different cities. So this could be your edge router, right? If this is on, let's suppose this is first floor, and you got second floor, third floor, fourth floor. Every floor has got a router. All these routers are connected to this router. This router will be called as an edge router. Understood? Wait.
Yeah, I understand, but I mean, if you look at the network is a hierarchy. So, for example, if you're using OSPF protocol, so you have a state of 0, and then you go in the next step or next level of layer, so it's become 1 or 2 or 3. So edge layer is actually the utmost layer of the networking. So, for example, in Amazon, which is also using more or less what do you call it, type of the Cisco's. So when they have defined the edge routers, means the edge router is the utmost uh, router, which is the customer always taking the information from the edge or CDNs, because in that case they can save the money instead for just asking the main routers from the headquarters or the other cities. So that's why I was asking, because your definition is whatever it is, it could be edge router. But again, because for example, Amazon is
Wait,
defining
your
very different.
example is very broad actually.
Mm.
In different scenarios, what you're given an OSPF, right? What
Yeah,
is there is areas basically in that, right? What were you
yeah,
saying about the OSPF? The backbone of OSPF is area 0, right?
yeah,
And
but,
edge router in OSPF is called ABR, area border routers. Those are area border routers which connects the two areas together. Those are
mm,
called edge routers, right?
okay.
Right. So basically, if you go from the OSPF perspective, then area 0 is considered to be the backbone area. But there are other areas also in OSPF, area 1, area 2, area 3, area 10, whatever you want to call it. But any router which connects to two areas together, that is called an edge router, area border router, right?
Okay. But,
So in Amazon, they might have one router which is doing basically not dealing with a lot of customer, but they're connecting different sites together. In that way, you can call that an edge router also. Understood?
Yes, thank you.
Edge router is not, written on stone that this can only be an edge router. Edge router, you can call it, basically the router on the stick kind of policy. What is router on the stick policy? Only one way out of it, right?
Yeah.
So you can look at it different scenarios and you can come up with that this could be an edge router in this scenario. This is an edge router for this scenario. OSPF is an edge router in this scenario when it's connecting two areas together. Any routers, let's suppose I have this router and I got 10 routers sitting behind me. And this router connects with other areas. That is called area border router. That is an edge router. Right? So same example I was giving you here. There might be 3-4 routers in Montreal, but this is connecting to two or different sites. So this can be called edge router. There's nothing wrong in calling it an edge router. But nothing is written on stone that this cannot be called an edge. Edge router is anything which connects to the outside or main primary router. Right? And OSPF it can be different. Amazon, the example you were giving me, it can be doing a different stuff. So, but depending on which scenario you're looking at. Okay.
Okay. Thank you.
No problem. Right? Where was I? Okay. Inter-VLAN routing. What is inter-VLAN routing is this. Luckily, I have this lab from Humber. Right? Now, what is this I created? I created this. This is a switch in Vancouver. Show VLAN. Okay. Now, what is happening? I call this VLAN number 10. And this port, whatever this port is part of this VLAN 10. So this port, FAST02, could be a marketing port, could be an account port. FAST03, let's suppose this is a marketing port. FAST02, you can call this an accounts port, right? Where the PC is connected to it. So I have assigned accounts, VLAN number 10. I have I have made this marketing as VLAN number 20. So what this inter-VLAN routing does, now if you look at it, there is only one physical cable coming from the switch to the router, which is on fast Ethernet 0/0. From this switch, I've got only one interface going from the switch. If I look at this, there you go, right here. And I was showing you guys this also before, right here. Let's look at this. Fast01 is which connects to the router, right? And on this router itself, it comes and cable is connected on fast00. My inter-VLAN now, basically the problem, there's a problem here. The problem is accounts team has an IP address of 192.168.2.0/24. And basically my marketing team has 172.168.12.0/24, right? Now you tell me, first of all, tell me this. The default gateway for these guys, for this subnet 192.162.0/24, any PC which connects to this FAS02, the default gateway has to be in the same range or it can be in a different range.
The default gateway should be the router itself, right? The connecting it to VLANs. Is that correct?
Yeah, but my question is something else, my friend. My question is, if I've got a PC connected on this VLAN 10, VLAN 10 subnet is basically 192.168.2.0/24. I got a PC 2.2/24. My question is the default gateway has to be from the same subnet, from the same range, or it can be from a different network or a different range.
It can be from a different network.
It can be from a different network. Anybody else?
I can just guess.
I don't think so. Yeah.
Okay, I got one. I don't think so. I got one. Yes. I got third answer is, guess.
Because what was in my mind, for example, like if we have two VLANs on a switch, then we have a trunk, which usually transmit the data to the router. So
Agreed,
that means
my
like
friend.
two. Mhm.
Agreed. Two different networks going across. That is all agreed, my friend. Right? But listen to my question though. PC connected here under VLAN 10. This is the subnet 192.168.2.0/24. Can the PC's default gateway be in a different network or a different
In
range?
that case, no, it has to be in the same range, same network.
It should, it should be the same.
Yep. Yeah, it has to be the same. Correct.
Okay, anybody else?
Based on what you were talking about, I mean, 5 minutes ago about the default gateway. So my assumption is it should be the same network.
Anybody else?
I agree with Vahid.
You guys are right. It has to be in the same range. Why? Because you send your information to the default gateway when you're trying to go outside of your own network. If your default gateway is outside of your own network, where the heck are you going to be sending this information to those packets to? You know what I'm getting at? Is this concept
Yep.
clear or not, guys? Yes?
Yep.
If you define, yeah, Mr. Imtiaz, if you define routing as 0000, so is it not this, I mean, way of bypassing the default gateway?
My friend, that is a different completely ball game, right? You guys understood this concept though. If you want to go to a destination network, then, or sorry, my fault. If you're trying to go to a network which is outside of your own network, you basically send the traffic to the default gateway. And if that default gateway is in the same subnet, then you'll be able to send it to. Otherwise, what would happen if your default gateway is sitting on a different network? You wouldn't know how to send it to. Understood?
It's the same as that you want to go exit from your home door. So instead for using your home door, you're using your neighbor.
Exactly. Right? So basically, F01 is a trunk port. Why? We talked about it in last on Monday's class. Trunk port is the job of a trunk port is take the tag traffic encapsulated with the VLAN numbers on top of your source IP, source subnet mask, destination IP, destination subnet mask, and basically your MAC address and all that kind of stuff. And it gets encapsulated with VLAN number 10, VLAN number 20, and it's getting sent across to router. So basically, if you have a trunk port, the job of a trunk port is to take the tagged encapsulated VLAN 10 and VLAN 20 number on top of the packet across. Otherwise, the trunk will, if you don't have a trunk, it will not be able to take the tag traffic from different VLANs across. So now when the packet comes into the router, we can only put one IP address under an interface. We cannot put more than that, right? What we have done, we have come up with the sub interfaces. These are virtual interface. So let's suppose this puppy sent the traffic for VLAN 20. Agreed for marketing. Packet comes into fast00 with an encapsulation of VLAN number 20 on top of a packet. When the packet comes into this fast00 and the router looks at it and he says, okay, your default gateway, my friend, is this one right here. If a packet comes in with an encapsulation of VLAN 10 and then FAS00 interface on the physical interface, he looks at it, okay, you're VLAN 10, my friend, this is your interface. So if you look at this guy, this is the default gateway for this guy. This is the default gateway for this person. But how the heck router would know? Let me just show you how I did it. Let me show you how I did it. This is how I did. So the packet comes in from this guy, switch, goes into the router, and this encapsulation .1Q10, this tells the router, hey guy, this is for VLAN 10. Anything which is tagged or encapsulated with VLAN 10, I am that IP, I am that interface. Any packet comes into the router with a tagging or with an encapsulation of 20, I am that interface for that VLAN. Understood, guys? This number can be anything from 1 to 65,000 or whatever you want to call it. But we always put whatever the VLAN number is here, because the only reason it's not written on stone, but the only reason we are putting it there is because if I have gone home, somebody else has come to troubleshoot it. As soon as you see these numbers, you say, okay, this is for VLAN 20. Oh, this is for VLAN 10. Right away, he's going to look at it. He's going to say, okay, this is for that. Understood, guys? Yes.
So means every time you're defining more than one VLAN, you have to inter VLAN. Otherwise, it's not going to work.
Exactamundo. Right? Because you know why? You can put only one IP address on the main interface, my friend. So what if this guy sends tagged traffic, encapsulated traffic from VLAN 10? He comes in here and he finds out that, hey, this is for VLAN 20. The default gateway, this IP is written here. So where are you going to put the default gateway for this guy? You know what I'm saying? For this 192.168. So that's why we create sub interface under the main interface. So anytime the packet comes with an encapsulation of 10, he right away note anything which with an encapsulation of VLAN 10, this is that interface they have to use as a default gateway. Anytime the packet comes in with an encapsulation of 20, he says, my friend, I am your interface. Now, if I have another VLAN over here with VLAN 30, 10.10.10.0/24, now you tell me that whether the packets are going to come over here or not. Does it have basically a default gateway defined here for it?
You have to define it in the left side as well.
Exactly. Let's suppose I configure it on the left side, right? Do we have anything here for that? For VLAN 30? Any packet comes in from the switch to this router. Do I have anything?
You have not defined the 30
Nothing.
there.
It's only
Nothing.
10 and 20.
So it's not going to be working, right?
Yep.
Agreed? No. What is that? No. 802. Okay. Oh.
Wasn't me.
No. No, somebody said no. Almas said no. Reply for the question you just asked. Oh, okay, my fault. My apologies. So this is what inter-VLAN routing they're talking about. Routers versus multi-layer switches. This is just
Sir, one more question, please.
Please.
So just to clear, like inter-VLAN routing is all takes place at the router instead of the switch, right? We only configure the switch. So once the packet transferred from switch to router, basically it's on the router end which decide, okay, which VLAN this packet is supposed to go.
Because you see, the thing is that this is the guy where the default gateway is defined, right? Routers, the layer 3 device is always the one where your default gateway is defined. So any PCs which is under accounts team, I might have some more interfaces with 190.168.2.10.11, 2.12, 2.13. For everybody, this would be their default gateway. If they want to go out on the internet, if they want to go to the Toronto office or they want to go to the Montreal office, they have to send the traffic to this interface on the router, because the router is the one which decides how to take the traffic to the destination. Just like our routers at home. On yahoo.com. Somebody else is on YouTube. Somebody else is watching TV. Somebody else is doing this. So my router is the one which is deciding where to take the traffic to, right? Same concept gets applied here. This is where all your default gateway gets defined. This is all your VLAN gets defined, right?
Got
Get
it.
it? So now multi-layer switches, as I said before, there are switches out there, high-end switches. There are so many high-end switches, which does your layer 2 and layer 3 both together. All this puppy, instead of here, is going to be on the switch itself, right? So they are basically more expensive. 6500, 7200, 5500, blah, blah, blah. There are so many numbers out there. Okay, this is basically switch network design. Layer 3, layer 2, and sorry, my layer 3, both of them are layer 3 distribution. Access is only where your basically PCs are going to get connected. Those are called access layer. Distribution route between VLAN and subnet. So basically, if they have got uh, VLAN 10, VLAN 20, VLAN 30, whatever that is, you can call it basically, inter VLAN routing. They're going to be connected for. Core router packet quickly crosses between distribution multi-layer switches. This could be your edge router, you can call it, and then this is basically you connect to the outside world. But this is only on paper. Realistically, nobody's going to be spending a lot of money doing this kind of design because this costs a lot of money, right? So basically, you simply put two basically layer 3 switches, depending how many people you have, and then you connect the users, and basically you connect to the router, to the firewall, and Bob's your uncle, you're out, right? But if you put too many switches, the problem is it's going to cost the narrow. It's going to cost basically your what do you call that? Your iOS is going to cost you, right? Your licensing is going to cost you, right? So basically, that's why on paper this looks great, but in reality, it doesn't get breakdown like this, right? And you have redundancy. Basically, we create redundancy between them. The redundancy means that if one path goes down, at least you have redundant path. And in these layer switches, these are not like, let's suppose if you got one card gone bad, right? So there are clips at the corner. You just, unclip it, take the whole module out, put a new module in. So it's not that you have to replace the whole device itself if something has gone wrong, right? In these access switches, 2960s, if the ports have gone bad, you have to replace the whole hardware. But in these basically layer 3 switches, these are basically even the ports. If the port has gone bad, you can just unclip it, take the port out, put the new port in, voila, it's working fine, right? Or if the card has gone bad, unclip it, take the whole card, put the new card back in. It's working. You don't have to replace the whole hardware.
Just like a hard swap.
Hot swap is basically called what? Hot swap is without turning the machine off while the system is up, you can take it out and put a new one back in. So it's up to you. Hot swap is basically a lot of these devices are hot swappable, but you can do that also. I've seen sometimes hot swappable doesn't work, but most of the time they do work. So hot swappable only means leaving the power on, taking the module out, putting a new module in. Understood?
Yep.
But essentially, as long as they're using the hot and standby module, I mean, so you don't need to change any cabling, do you?
I'm sorry. Can you please repeat your question?
Well, I mean, if the ISPs, for example, or the companies, they're using the hot and standby routers,
Mhm.
So you don't have to change or remove any cables. So because one is standby and one is working, and as soon as goes something wrong, so the traffic moves to the other one automatically.
Absolutely, it does. But what if you have basically user ports coming in, right? You always, I totally agree with you. You use hot standby routing protocol BUs or VRRP BUs. What those are, what you're talking about is basically saying one is your active, the other one is standby. If something happens to the active, the standby basically takes over and become active, right? But what
Yes.
I'm talking about is basically not HSRP or VRRP protocols. What I'm talking about are the ports. If some ports have gone bad or a module has gone bad, you know, the like 24 port, like or 48 port cards in it. If the whole card has gone bad, we can just unclip it, take it out, put a new one in.
Yeah, okay, that's a different story.
That's what I'm. That's what. That's the sort. That's the story I'm trying to tell my friend. And you're talking about HSRP and VRRP protocols.
I just wanted to know that you are backup or not.
Yeah, I am up. You guys got my videos on. I'll be snoring, right? So basically, let's go look at this. So we were talking about this multi-layer switching. Same thing what we we're talking about. Now, this is what you were talking about earlier, right? What you were talking about earlier is basically the static routes, right? So what static route we were talking about is basically if I have this right here, right? Give me a second. Give me 1 second. Okay. Okay. So if I have this Vancouver, I've got this Toronto, and I've got this Montreal, right? I've got these three sites, right? I'm just going to give you a little bit. I'm going to probably go in more detail in the next class. What this does, it simply says IP route 0.0.0.0.0.0.0. This means any network, any subnet mask, send it to my next hop IP address. This is Wahid, what you were mentioning earlier, right? So if my Vancouver is
Yes.
here, my Toronto is here, my Montreal is here. Now, in this case, I'll be saying to my Vancouver, if you want to go to any of the routers, any of the network, simply send all the traffic to my next hop IP address, which is on Toronto, which means send everything to Toronto. That's it. Punto. That's what it means. This is called static route. Understood, guys?
So
Yes.
This is not it's not called the last resort as well.
Can you repeat that, please?
Last resort.
Yeah, because you see, this is only way out for you,
Mm.
right? Only way out. Now, if I close this and I open my static route, let me see if I have static routes here. Okay, here we go. I have this here. Now look at this, guys. Look at this. I got my Vancouver. I got my Toronto site. I got my Montreal site, right? Now look at this. In my Vancouver site, I am connecting to Toronto site. You guys see this? 175.175.175.1, which is this IP address. 175.175.175.2, which is this IP address. Understood, guys? Do you guys understand this, what I'm trying to explain here? Any questions, stop me here, because if you guys understand this, then it will be easy for me to explain the static route. Any question, confusion here?
You have a serial connection between two routers, right? Between
Yeah,
two cities.
but the way that's not what I'm trying to show you, my friend. What I'm showing you here is you got Vancouver, you got Toronto. It's connecting on this interface, and this is the IP address on this end. This is the IP address 175.175.175.2 on this end. Because why? I'm using a /30. In the /30, if you calculate, you can have only two usable IP address. One is the network, two usable IPs, one broadcast, and then the new network. Any confusion here, guys?
It's so clear.
Everything is clear? No questions? Let me look at the chat and see if anyone has typed. Otherwise, I'll be looking at it after 15 minutes. Okay. Right? What I wrote here for Vancouver, I said IP route 0.0.0.0, which means if I want to go to any destination network, if I want to go with N to any subnet mask, simply send the traffic to this person on my other end, the next hop IP address. For Vancouver, this is my IP address here. And for Toronto, this is the IP 175.175.175 to do. So what I'm saying, do not drop any packets, simply send the traffic to Toronto. Understood? Now, I got a question for you guys before I let you guys go. Understand this concept very closely. If I am sitting in Toronto, I have got this network here, this network here. In Montreal, I got this network and I got this network. If my PC comes into this, right? If my PC, let me rephrase my question. If this PC wants to go to Montreal, where would it be sending its traffic to? This executive PCP-PT, where he would be sending the traffic to? Just by
So
looking at the diagram, don't look at the configuration yet.
Toronto router
And what is on the Toronto router that he's gonna decide to send the traffic to it?
through the routing table.
No, my friend, there is no
Through the
routing table on the PC, right?
through the switch.
What is, I'm sorry? Somebody said something. Okay.
you are sending to the Toronto router, and then Toronto router is
But
using the
my friend,
static
what is that
static
Toronto
traffic.
router for this PC? That's what my question is. If
Oh,
he's
default gateway.
exactly, because you see, look at this, guys. This is what my question is. If this PC-PT executive wants to go to Montreal, then he would be sending to who? To the Toronto router. To where? To its default gateway. Comprende? So this puppy comes in here. Now let me ask you something. Can I put a default gateway on this Toronto router? What I just explained to you about the default gateway, can I put it on the Toronto router facing Montreal?
Now, actually, you can do that because they are sitting in the same subnet.
Eh? Where's my same subnet, my
Yes.
friend? Where are you looking at?
Well, it's not so clear here because it's so small, but I
Is
suppose
it
this
small?
PCs.
Is it? This is one, sorry, this is 158.2.2.2/24, and he's trying to go to the IT department, which is 188.188.188.2.
Now, what I was trying to say is between the PC and Toronto router. So since the Toronto router is working as a default gateway, so both of IPs should be in same network. From Toronto router, you're using a static router routing and sending to the next. I think is Vancouver. No, is the other one. Where is it?
This is
It's
Montreal, my
Montreal.
friend, he's trying to go to,
Yeah.
right?
Because so as I said, it's so small, I cannot see exactly what's written.
Can you see now? No?
Yes, now it's better than before.
It's better than before, but
Yeah,
How
why
about
you
now,
can
man?
open the magnifier?
This one?
yeah,
It's not a
you have to
magnifier,
use the
is it?
other one because that goes.
No, man. It's not a magnifier, is it?
Oh, the next one. Yeah, that one. No, to
No,
the
that's a
left side.
box.
No, to the
On the
left
left
side.
side, left side,
That
left
one.
side. Oh, here you go, right here. Okay.
Fast.
What am I doing here? Oh, this is the. Okay, you know what? Heck with that. Can you see now?
Yes,
Okay.
that's okay.
So this 158.2.2.2 wants to go to Montreal 188.188.188.2, right? Now my question is, can I put a default route pointing from Toronto to Montreal for him to send the traffic to this guy, and default route 0.0.0.0.0.0.0.0, next hop here. Can I do that?
Yes.
Definitely yes.
Fine, everybody agrees. Now, if this executive wants to go to Vancouver to this guy, 192.168.2.2, what would happen then?
It do not go there.
Where would it go, my friend?
Montreal.
Okay, is he right? Is he wrong? Or is he sleeping?
I guess he's right because the traffic would be going to Montreal, and then from there would be no route to go back to Vancouver. Uh,
Exactly. If I have a default route pointing to this puppy right here in Montreal, and the executive, fine, if it wants to go to Montreal because of the default route 0.0.0.0.0, he's going to go to Montreal. But if this executive decides to go to accounts, which is 192.168.2.2, then what would happen? Because of this puppy right here, the 0.0.0, he's going to be sending everything to Montreal, right? He sends here, he says, I don't know what the heck is 192.168.2.2. It's not here. He's going to simply drop the packet.
You are
Sorry?
going to define another one for the Vancouver.
Exactly. So my default route would not work, my friend. So I would need two routes. One, okay, so
one
just
for
tell me that
Montreal and the other one for the Vancouver.
just by looking at it, how many routes do I need? How many default static routes would I be using? Think about it, guys.
Three of those.
Two.
I got two.
One.
Oh,
I
two
would say
where, my
three.
friend? I got three, I got two, I got one.
So one should be between Toronto and Vancouver. One should be between Montreal and Toronto, and then one, two, three. Because every interface should be like having a route. So, for example, if Toronto like is having three kind of connectivity, one from the local and then two
The
other.
local, my friend, the local is already, Toronto already knows what is
Oh,
sitting
okay.
behind him locally,
Yep.
right?
So two. Yeah, I
Now,
should. Yep. Gotcha.
okay, now let me ask you something who's saying two, right?
Mm-hmm.
You got how many networks first? How many networks you got in Vancouver? How many networks you got in Montreal? Let me enlarge it a little bit.
One
So
net.
local, only one. Locally, there is only one
Two,
network.
two, 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 two.
How many networks sitting in behind Vancouver?
One only.
Two. There are
Man,
two.
Two. One is a 188, the other one is 200.
everybody agrees.
Yeah.
Vancouver is 192 and 172.
Exactly. So you
Mhm.
got two networks sitting in Vancouver and two networks sitting in Montreal. 188, 188, 188, 200, 200, 200. In Vancouver, you got 192.168.2, and then you got 172.168.12. See that? So how many static routes do I need from Toronto?
4.
4 of those, so 2 for
Exactly.
each.
2 for each.
Yeah.
Because otherwise, if you don't put 4, what would happen? You will be saying IP route for this network, send the traffic to Vancouver. For this network marketing, send the traffic to Vancouver. For this network sitting in Montreal, send the traffic from Toronto to Montreal. And then for 200, also send it to Montreal.
So that means we have to define everything in the Toronto. So then he knows like where we have to send the traffic.
Exactly.
Okay.
Right. But now, let me ask you something. How many do you need in Montreal and how many do you need in Vancouver?
2 on both, like
Mm-hmm.
oh, 4. You can say 4 because here and there both sides.
Can you explain what you're saying? I'm sorry, what is your name?
Zishan.
Zishan? Okay. See if Zishan is right or not. What you just said,
I
explain
said
to me.
like 4 in Montreal as well, because if the traffic come towards the Montreal, then he will send it back again to
Okay.
Vancouver.
But let me ask you something. Which 4 networks are you talking about, my friend?
For like 2, the one which is 192, I can't see, 200 as well.
Sorry. Sorry. So basically what he's saying is 4. So 2 for Vancouver network and 2 for Toronto networks. Am I right?
Yes.
Right? And what about Vancouver?
Yeah, so Vancouver 2 and 2 Toronto 4.
Is he right? Is he wrong? Or he needs coffee?
I guess he's mentioning Montreal as Toronto.
No, my friend. What he's saying I need to put 4 lines in Montreal. And what he's saying, I need to put 4 lines in Vancouver. Why? Because you got 2 networks sitting here and you got 2 networks sitting here. So fine, you got a packet coming in here, but does he know how to go back though? What is ping? Sending a ping and you getting a reply back, right? Yes?
So isn't it always full duplex?
No, full duplex is something else, my friend. Full duplex is when when your PC is connected on a switch right here, you can send and receive packets both at the same time. But this is routing, my friend, right? In routing, these routers are just dummy terminals. You have to tell them in order to get to here, you need to do this. In order to get to here, you need to do that, right? Static routes works differently than dynamic routing protocol. And we'll talk about dynamic later on.
So if that's the case, then
So
he's right. Like,
for every router, you have to define 4 static routes,
yeah,
right?
4 for each location. So
Mm,
2, 4.
that's the question. Do you need 4 static routes for every single router?
I would say yes,
I would say no.
because for static routing, for example, you have to kind of mention every possibility to the router. For example, if else, to make sure like if a packet is like going there, it can be routed back to the same router.
Okay. Anybody else?
What about having a trunk between switch and router?
That's a different ballgame, my friend. That's what we talked earlier, right?
Mm-hmm.
That's the trunk port.
Mm-hmm.
That's a trunk port, switch and router. We can having connection between this LAN. This is the LAN we talked about earlier. Now we are trying to understand this, how to send the traffic from here, Vancouver to Toronto, and from Montreal to Toronto. What I suggest, read on it. Next class, inshallah, we will talk about it. Again, wake up, right? Think about it. If I need to send something, I need to get a reply back, right? So whatever I
Correct.
send, I need to get a reply back. Simple as that. Think on those bases.
All right.
And
Sure.
right.
Yep.
So think about it, how the static works, and can I have a static? Well, my points are this. Think about it. You can put a default static route here. You can put a default static route here. But you
Mm-hmm.
cannot put a default static route over here. You need to have for two networks here pointing to Vancouver. For two networks, you have to point to this one. But on this one and this one, you can put a default static route. Why is coming in the next class, my friend? But think about it. I want answers.
Sure.
Okay, guys. Any
Yes, sir.
question? Let me see. Must set up a default route for both. Okay, I'm sorry. I'm too late. Sorry, Elmas. I read that. Your chat late. Okay,
Uh,
guys.
Uh,
so just one more
Imtiaz, can
question
you
out
get a
of this
copy of
context.
this trace package file?
Sorry, two people were asking at the same time.
I was asking a question out of this context, sir. Wanted to ask you about the I drag ports on the router.
I drag ports? What is that, my friend?
Like drag port.
DRAC?
Yes.
DRAC ports.
Yep.
The drag ports. What are those, my friends?
I'm not sure, sir. What I got to know is like these are kind of ports which can be accessible even if the router is offline. So whoever is the administrator, if someone like from let's say from the back team who are basically managing the routers, if the port is connected to the drag port of the router, so even if the router is offline, they can access it. That's what I got to know about that port. So just wanted to ask you about some more details.
Oh, you're talking about the backup path, like out of band access, async port, right?
Maybe, sir, if that's the
Like
same thing.
getting connected remotely. This is the first time I'm hearing this called drag port. You know, is basically what we call in an networking is basically a remote connection to the router or a switch or anything like that, right?
Mm-hmm.
The network management connection basically. But drag port I've never heard, my friend. This name I've never heard. You know,
Okay.
so it's basically if something happens to this router from Toronto, you can dial into it remotely into a modem, and then from modem it basically gets connected to this Vancouver router.
Yes,
If
sir.
this class is back.
That's what my understanding is. But I don't know the detailed thing, like how it works, like what's the architecture. But I just recently got to know there is a drag port on the routers. For example, if the for some reason there is no connectivity, but still the management team can access that
Dial out of
router.
band into it or have a DSL port basically.
Yep.
And then from there, you can get connected. Yes. It's called a backup path basically. A backup, we do dialing into it or network management connection into it. Just in
Okay.
case if the main primary connection goes down, then
Mm-hmm.
basically you use that in order to get to it.
Okay.
Okay.
Uh,
Okay, guys.
Imtiaz,
Sir, yes,
is
sir.
any way that you can get a copy of this file?
This what?
Packet trace copy of this packet trace file you have on the screen.
Okay. Uh,
Well, I'm interested in the configurations.
can I upload this puppy here? Upload files. Okay. That OSPF. Let me see if I can add more. Control static. Then I have Eigrp open. Uploading 3.
Thank
Uploaded,
you.
my friend. But if you
Thank you.
please make sure you download the packet tracers also, right?
Well, I have already.
Perfect. Okay, guys, have fun, enjoy. Shall I see you on Monday? But please do look at this diagram and see, where this static routes and default. You understand that.
Sure. Thank you. Thank you
Thank
All
you,
very
right,
sir.
much.
guys. Thanks, man. Take care, guys.
Office.
Okay, Khuda Hafiz.
Love this.
Khuda Hafiz.